Let's get started with chemical energetics. Chapter 5, Energetics of a Reaction. Lesson outcomes. Describe the meaning of exothermic and endothermic reactions. Describe bond breaking as an endothermic process and bond forming as an exothermic process. Interpret energy level diagrams showing exothermic and endothermic reactions. This chapter mainly focuses on the core syllabus of IGCSE 5.1, Exothermic and Endothermic Reactions, which state that an exothermic reaction transfers thermal energy to the surroundings, leading to an increase in temperature of the surroundings, and to state that an endothermic reaction takes in thermal energy from the surroundings, leading to a decrease in the temperature of the surroundings. So let's dive deep into it. Exothermic reaction. The exothermic reactions usually transfer heat energy to the surroundings. This is seen as a rise in temperature. For example, is burning of wood. When the wood burns, the heat energy is released into the surroundings. The heat coming out is an example of exothermic reactions. It means the thermal heat exists. So exiting of heat is exothermic. Endothermic reaction. Best example of endothermic reaction is melting of ice. Here we can see that this energy from the surroundings make the ice convert from a solid state to liquid state. Thus, energy is needed to push the molecules farther apart, hence changing the state of matter. This picture clearly shows the difference between endothermic and exothermic reaction. The heat energy is transferred into the system. In an endothermic reaction, as such it says, enters heat, endo, thermic, and exothermic. Heat is transferred into the outer surroundings from the system. Thus, these chemical reactions involve energy transfer between the system and its surroundings.
Photosynthesis. Photosynthesis is an endothermic reaction. You know what endothermic reaction means. It is the absorption of energy. Now, how is energy being absorbed in photosynthesis? It happens because of sunlight. Sunlight is a form of energy that is being absorbed by the leaf along with water and carbon dioxide. The formula for water is H2O and the chemical formula for carbon dioxide is CO2. Now you need to remember the equation for photosynthesis. That is 6 molecules of carbon dioxide, that's CO2, plus 6 molecules of water, that's H2O, in the presence of sunlight gives you C6H12O6. C6H12O6 is glucose along with oxygen, and that oxygen is 6 molecules. Cellular respiration. Cellular respiration is an exothermic reaction, not an endothermic reaction. That's why it's different. In this, the energy is released from the glucose molecule. It's just the opposite of photosynthesis. In this, the equation of photosynthesis is reversed. So what happens is glucose along with the 6 molecules of oxygen, that's O2, gives 6 CO2 plus 6 H2O. CO2 is carbon dioxide and H2O is water. Exothermic reactions don't always release heat. Sometimes the energy is being released as light. For example, glow sticks. Glow sticks release light without increasing in temperature. If the temperature increases, that means heat is being released. In this case, temperature does not increase. It means no heat is being released. Is respiration an exothermic reaction or an endothermic reaction? Please note that respiration is an exothermic reaction because the energy is being released. Respiration is the process that the body uses to release energy from digested food. That's glucose. So the glucose, which comes from the digestive system, along with oxygen when we breathe in air, gives carbon dioxide, which is a waste product because our body does not need carbon dioxide at all, so it's exhaled. You breathe in oxygen and exhale carbon dioxide, along with water and some energy. Sodium hydroxide solution is poured into a beaker of hydrochloric acid. The thermometer shows the initial temperature, which is the room temperature. The beaker now contains sodium chloride and water. The temperature on the thermometer has risen, meaning it is an exothermic reaction. Exothermic reaction and endothermic reaction that occur at room temperature in the science lab can be investigated using a thermometer. Exothermic reaction examples. There are a few examples here, that is formation of snow, burning candle, burning wood, and gas burner being used in our kitchens. Here are some things to remember when you're conducting this type of experiment. Please conduct the experiment in a polystyrene foam cup. This insulates the mixture and makes the results more accurate. Record the temperature of the chemicals before they are mixed together. Record the highest or lowest temperature of the mixture after the reaction has occurred. If the temperature of the mixture has gone down, the reaction is endothermic, and if the temperature of the mixture has gone up, the reaction is exothermic. An insulating polystyrene cup with a lid will make the results more accurate. It would prevent the heat from escaping out of the cup during an exothermic reaction, and it would also prevent the heat from entering the cup in an endothermic reaction. This makes the results more accurate. Here are a few questions. I'll be reading out the questions and explaining it wherever needed and giving hints. However, I prefer you try these questions out and check the answers at the end of the video. The first question says, what word is used to describe a reaction that absorbs energy from the surroundings? It means energy is being taken inside, it's utilizing the energy or absorbing the energy. The second question is, what kind of reaction is combustion? Combustion means burning. The next question is, when copper carbonate is heated, it absorbs energy and breaks down into copper oxide and carbon dioxide. What kind of reaction is this? The answer is really very easy. First of all, you should remember not to panic whenever you see words or names that are not familiar to you. You should just notice the key words in the question. For example, in this question, the key word is absorb. So in a reaction when the energy, as it says over here, is absorbed, what reaction it is called? Ammonium chloride and barium hydroxide are mixed together. At the start of the reaction, the temperature is 20 degrees Celsius, and at the end of the reaction, the temperature becomes 3 degrees Celsius. Which statement is correct? You should notice that here the temperature is decreasing and not increasing. When temperature decreases, it means the mixture is being cooled. Small pieces of calcium metal are added to some cold water. At the end of the reaction, the temperature has increased to 47 degrees Celsius. Which word describes this reaction? Here, the key word is the temperature has increased. So, increased temperature means the mixture has heated. Now, let's study the meaning of the terms conduction, convection, and radiation. Conduction means the transfer of energy between adjacent molecules. Convection means movement of a hot fluid. Radiation means the emission of electromagnetic rays. There are three mechanisms of heat transfer. Firstly, it's the conduction. Conduction is the flow of heat by direct contact between a warmer and a cooler body. Second, convection. Convection is the flow of heat carried by moving gas or liquid. For example, warm air rises up, gives out heat, cools down, and then falls. So this is the flow of heat. Radiation. It is the flow of heat without the need of an intervening medium. By infrared radiation or light. Bond energy. This is the energy released when a bond is formed or required when a bond is broken, respectively. The unit measure of this energy is kilojoule per mole. The energy change in the reaction is calculated using the following formula. That's delta H is equal to bond breaking minus bond forming. Please remember that if the overall heat value, that's the delta H, is negative, then the reaction is exothermic. That means the energy is released. And if the overall heat value, that is the delta H, is positive, then the reaction is endothermic. To understand this much more better, here's an example. Hydrogen plus chlorine gives 2HCl, that's 2 molecules of hydrochloric acid. Now for finding out the bonds, it's really simple. First, you should see the reactant side. On the reactant side, that's the left-hand side of the arrow, you have hydrogen and chlorine. Hydrogen has two bonds or two hydrogen molecules, so that's H and H. Chlorine has two, so chlorine with chlorine, it's a bond. And then coming to the product side, it's hydrogen along with chlorine after the reaction. Now the bond energies are given next to it, 436, 243 and 432 kilojoule per mole. Now you need to find out the energy that's required to break the bond, that's bond breaking energy. You just simply have to add the two bond energies of each bonds. So on the reactant side, as you can see, both the molecules are separate. You can just add 436 and 243 kilojoule per mole to get the bond breaking value. That's 679 kilojoule per mole. And now for bond forming, after the reaction, a product is formed. So that means the bond is already formed. You just simply have to multiply 2 into HCl. HCl's bond energy is 432. So 2 into 432 gives 864 kilojoule per mole. Thus, the delta H, that's heat energy, is 679 minus 864. That is bond breaking minus bond forming. The formula was given in the previous slides, which is minus 185 kilojoule per mole. Now, as you can see, the value is negative. That is why it's an exothermic reaction. Bond energy calculations. Here's an example. Calculate the energy change when water is formed from H2 and O2. On the right-hand side, you can see that the reaction is given in the bond structures and not the normal reaction. but it's the same, but it's also balanced. So that means the right hand side as well as the left hand side moles or molecules are equal. Now how to do the calculations? Step 1 is find the value of bonds broken. For that you have to calculate the bond energy for each of the hydrogen and oxygen. For hydrogen, as you can see in the reaction, there are two bonds, the HH and one more HH, in total 4. So what you can do is multiply 2 with one HH bond. That's 2 into HH, you can see in the steps, is equal to 2 into 436 because one HH bond energy is 436 kilojoule per mole, which is equal to 872. Now for finding the oxygen bond energy, you can see that there is only one bond for oxygen. That's why 1 into OO. For oxygen, there's always a double bond. For other all, there is single. For some other exceptions, there are triple bonds. That's 3 bonds. So OO, that's you can see in the last, it's 498 bond energy. So 1 into 498 gives 498. To find the total energy, you have to just add both the values. That's 866 and 498, which gives 1370 kilojoule per mole. Now the step 2 is bonds made. Bonds made means bonds formed. For that you have to see the product side, that's the right hand side. As you can see that there are 4 OH bonds. Now OH means oxygen and hydrogen. Now 4 into OH is equal to 4 into 464. How did we get 464? As you can see on the table, OH bond energy is 464 kilojoule per mole, which gives 1856. Now step 3, which is the final step, asks us to find the energy change. Energy change means the delta H. So that's bonds broken minus the bonds formed. 1370 minus 1856, which gives you a negative value. That's 486 minus 486. The negative sign means that it's an exothermic reaction. Now this is a little bit higher level question as it involves nitrogen. Nitrogen has triple bonds, but you don't have to worry seeing the number of bonds if it differs. The maximum number of bonds a molecule can have is triple only, and that's nitrogen. So the question asks, nitrogen and hydrogen react together in the following reaction. Nitrogen plus 3H2, that's hydrogen, gives 2NH3, that's 2 molecules of ammonia. Calculate the overall energy change for this reaction. So firstly, you need to write it in the bond form reaction. Now N2 can be written as N triple bond N added with 3H2. That's 3 times you need to write the HH bond. That gives NH3 and NH3 because in the reaction you can see it's 2 molecules of NH3. Firstly, to find the overall energy change, you need to find the energy required to break the bonds and then subtract it from the energy released by forming the bonds. To find the energy required to break the bonds, you just need to add the left hand side or the reactant side. For that, find the energy, bond energy between nitrogen and add it with the bond energy of hydrogen. For finding the bond energy of nitrogen, it's simple. As you can see, there is only one molecule of nitrogen. You just need to look at the main reaction, that's N2. The coefficient is 1. Nothing means 1. Okay. So 1 N2, that's 941 in the table it's given. N triple bond N bond energy is 941 kilojoule per mole. So 941 plus 3 molecules of hydrogen. Hydrogen is 3 times, so you take the bond energy for HH, that's hydrogen, 436 into 3 times. Now add both these values and you get the energy required to break the bonds. Now coming to the energy required to form the bonds or the energy released, you just need to find out the number of NH bonds, because in the table the molecule NH value is only given, or the bond energy for NH. So on the product side you can see that there is 1, 2, 3, 4, 5 and 6 bonds of NH. What you need to do is multiply 6 into NH bond energy. So NH bond energy is 391. So 6 into 391 gives you the forming of bond energy. You just need to subtract both the values and you get your answer. Reaction profile. Now you're going to learn the graphs for exothermic and endothermic reactions. As you know, exothermic means the energy is released into the surroundings. So the graph has the energy on the y-axis and progress of the reaction on the x-axis. How you can differentiate between exothermic and endothermic graphs. So you should notice carefully that the reactants line that's given in the green in the graph is a lot higher. So that means it has more energy, and the products line is very low. It's at a lower level, so it has less energy. That's how you can remember the exothermic reaction. And also exothermic reaction means the temperature, it increases. Lots of heat energy would be released. When fuels are burnt, that's combustion happens in the presence of oxygen. That is also an exothermic reaction. Oxidation is also an exothermic reaction, and also neutralization. Neutralization is the mixture of acid with base, which gives you a salt. Now the endothermic reaction, that means the energy or the heat energy is taken in or absorbed from the surroundings. In the graph, you can see it's the same. On the y-axis, there's the energy. On the x-axis, there's the progress of the reaction. But here, the reactants is at a lower level as compared to the products. Products is at a higher level. So you can see that the energy is absorbed. That means the energy is taken in by the products. For example, calcium carbonate in the presence of heat gives you calcium oxide and carbon dioxide. Here carbon dioxide is the gas. This slide shows you the clear picture or the difference between exothermic and endothermic. You can easily identify since the reactants is at an upper level or higher level compared to the products. It means it's an exothermic reaction. In the second graph, the reactants is at a lower level. That means it's an endothermic reaction. The heat is absorbed. Activation energy. It is the minimum amount of energy the reactant particles need in order to collide with each other and react. As you know, many reactions take place. For example, even the formation of water or burning of magnesium, everything. So how does the reaction take place? That's because all the particles in the reactant side, they have a minimum amount of energy because of which the particles collide with each other, and that's when the reaction takes place. If that minimum amount of energy is not present, the reaction would not take place. You can see the graphs for exothermic reaction and the endothermic reactions once again. These graphs here show the activation energy points. For the reactants, it's at the highest level, and even for the products, you can see where the point is, and that is when the reaction actually takes place. Reaction of magnesium with hydrochloric acid. Magnesium reaction is magnesium plus 2HCl, that's 2 molecules of hydrochloric acid, gives MgCl2, that's magnesium chloride, along with hydrogen gas, which is evolved. So the reaction is that the reactants is on the upper level and the product is at the lower level. That means it's an exothermic reaction. And how else can you identify it's an exothermic reaction? That is because the H2 gas is evolved or the gas is released and no heat is used in the process. H2 plus Cl2 gives you 2 molecules of HCl. Now you can see that this reaction is both endothermic as well as exothermic. It means it needs heat as well as it releases heat after the reaction. The graph of this reaction contains both the graphs combined together. Now there's another example between calcium carbonate in the reactant side and calcium oxide along with carbon dioxide on the product side. The graph has energy on the y-axis and reaction progression on the x-axis. You can see that the reactants, the energy put in to break the bonds. So the energy just goes up and then the energy is released when the bonds are made. So it just goes down to form the products. Now you can see the delta H, that is the energy taken in from the surroundings. So that is the exothermic reaction, and in the starting it was endothermic reaction. Now we'll see the summary of this chapter, endothermic reactions and exothermic reaction, the differences. Endothermic reaction, just write the definition. The heat energy is absorbed from the surroundings, and exothermic reaction, the definition, the heat energy is released into the surroundings. Then comes endothermic is a bond breaking reaction. It means the bonds are broken whenever endothermic reaction takes place. An exothermic reaction is a bond making or bond forming reaction. It means whenever the energy is released, bonds are made. Then finally, surrounding temperature decreases in an endothermic reaction. When heat is utilized, the energy or temperature decreases. An exothermic reaction, the surrounding temperature increases. It means heat is released.